Yeah, hello, my dears. So in this part, we are going to learn about the nucleophilic substitution reactions of the alcohols. Okay. So first, alcohols, we know that basically we are having that primary alcohols means 1 degree ROH, okay, primary alcohols, secondary alcohols, tertiary alcohols. Okay, so how is that primary alcohols, secondary and the tertiary alcohols is participate in that nucleophilic substitution reactions with the help of any reagent. Okay, chalo beta, let us learn. So first, before going to start, first here, I would like to write that one reaction that is nothing but when alcohol is reacts with the X minus, where that X minus can be as that nucleophile, let it be. So what is going to be replaced better here? That OH minus should be replaced by X. So then how can we write RX? Okay, whereas OH minus should be as what? Here OH minus should behave as leaving group, whereas that X minus should behave as attacking group. Okay, then OH minus should be leaves out. OMG, is it the possible like this type of that reaction? Huh? Is it possible? No. This type of the reaction is that not possible. Why? What is the reason? Let us see. Yes, beta. So let us know that there are few points regarding about this that reaction. So as I said, so this type of that reaction is that not possible. So why? Let us see the reason. Okay. So first of all, any type of means any alcohol. Okay, any alcohol. It's a can't undergoes. It can't be undergoes Sn reaction. Okay, it cannot be undergoes Sn reactions. That means that nucleophilic substitution reactions with whom better? With hmm? With whom? Like this, that here I take in C, here I take in X minus. So that means that halide ions with the halide ions. Okay, why? What is the reason? Okay, why it is that alcohols like that cannot undergoes that substitution with that halide ions? Because see, I will show you. So see beta, why here? So alcohols means what here? OH minus. Okay, these type of that compounds cannot undergoes that ఏం చెప్పాను నేను ఇక్కడ nucleophilic substitution reactions with the whom halide ions, with the halide ions means X minus. Why is that alcohols cannot be replaced by that halide ions? Because here halide ions are, it is negatively charged ion. So negatively charged ions is nothing but what? Basic nature. What type of basic nature? Halide ions is that weakly basic halides. It is a weak weak basic nature. This one OH minus, this one is also basic compound. It is also shown basic in nature, but it is a strong basic in nature. Okay, so obviously we know that the strong people can't go to that weak people. Means that strong people cannot replace it with that weak people. Always that weak people only can be replaced with that strong people. Likewise here the OH minus being as that strong basic. Okay, I think that now you got my point. Okay, What is that? Alcohol. So generally, so once again, I repeat, alcohols cannot undergo Sn reactions with the with whom halide ions. The reason is that they are that weakly basic halides. So that weakly basic halides cannot be replaced by that strongly basic of OH group. So that's why this reaction is not possible. Clear, beta? Okay. If, however, if, however, if hydrogen halide is used, okay, if HX hydrogen halides are used, then as a reagent, used as what? Hydrogen halide is used as what? Reagent. Okay, then that alcohols gives SN1 reaction. Then alcohols gives Sn1 reaction, because you know, like this, that hydrogen halides, they are converts. How they are going to be converts, beta? First, this, that hydrogen halides are converts alcohols. Hydrogen halides are converts ROH groups, means alcohols ని ఏ విధంగా కన్వర్ట్ చేస్తుంది? HX na, like C, H plus X minus. So whenever there is that H plus X minus na reagent hydrogen halide, so ROH is that substrate. Let it be that one of the substrates. So this one should be the first converts to ROH, and one more hydrogen is that attack here, like that X minus can be leaves out. So that's why that oxygen is contains positive charge. So that means, so by what? So you could attack in the proton. So that's why the first that ROH converts like this type of that product by protonation. Okay. Otherwise, simply we can say that S3O plus also, like that. So let it be, suppose instead of that alkyl, if we taken that one more hydrogen is there, okay, then it will be converted to what? To just, sorry, we can say as that S3O plus. So whereas this compound is related to, it is a good living group. It is a good living group. Clear, beta? So in this case, the reactivity of HX means what? Whether it may be HX hydrogen halides, means we can get it as that HCl, HBr, H iodide. Okay, so the reactivity of these that hydrogen halides is gradually increases. We know that the reactivity of the hydrogen halides is increases. Clear? So which one is having that more reactive towards the nucleophilic substitution reactions, like that hydrogen iodide? Clear? So here tertiary alcohols, suppose tertiary, any alcohol can't undergoes that, okay, Sn reactions. Actually we know that Sn1 reactions can give by what? Sn1 reaction is favored by primary, secondary, or tertiary. The tertiary alcohols, okay, and Sn2 reaction is favored by primary alcohol. We know that. So here what I mean is that the tertiary alcohols gives this one. The tertiary alcohols gives Sn1 reaction, whereas the secondary and that primary, not only that primary, secondary and the primary alcohols whose beta carbon is whose beta carbon, the primary alcohol. See better that here I would like to give that one example of that primary alcohol. Say CH3 CH2 OH. Okay, this is the primary alcohol. Okay, now so this is that alpha carbon and this is the beta carbon. So what I'm going to say is the secondary alcohol, that primary alcohol, who's the beta carbon. This one is that beta carbon, isn't it now? So the beta carbon is should be tertiary or quaternary. If this one beta carbon is also CH3 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 like this. Okay, so this beta carbon is also, if it is belongs to what, tertiary or quaternary, then it is also gives SN1 reaction. While మరి SN2 ఎప్పుడు ఇస్తుంది బేటా? SN2 ఎప్పుడు ఇస్తుంది? While primary alcohols, while this is the example of that primary alcohol whose beta carbon, this one is only beta carbon is a primary or secondary, అంటే tertiary or quaternary అయినప్పుడేమో it gives that SN1. If this that beta carbon is primary or secondary, then it gives SN2. Very important points. Okay, now don't get confused. If you want, just go back and that listen carefully. Okay, chalo beta. Let us see the mechanism. Okay, beta. So now let us continue that mechanism for that SN1. So in this, that SN reactions of the alcohols is that the basic form, little bit that introduction just we learn now. So further, now we are going to learn about that mechanism for that SN1. Okay, now here I will get that one alcohol. So SN1 reaction is that favored by that primary alcohol, yeah, secondary alcohol, yeah, tertiary alcohol. Chalo, guess. Yes, it is a tertiary alcohol. So now in the mechanism, first I am going to get the tertiary alcohol of one example. Okay, beta. So here I taken that one of the example for what? SN1. So here it is belongs to. So could you say that what is the example for the this belongs to tertiary alcohol, isn't it? Now this belongs to tertiary alcohol. So obviously that the tertiary alcohol is that favored to SN1, isn't it? Now, so first what happens, like this, that H eggs, okay, H plus X minus, okay, first H plus is going to be attack and over here lone pairs, as I said in that previous, just then it forms, it converts into what, because here just I'm doing that protonation beta. So then it gives a protonium ion. So once the protonium ion is obtained, it can behave as a good living group. So don't forget this one. Okay, chalo. So after sorry, after attacking of this that protonation, now the product just I'm writing like this. See beta, now the product is just I can write like this, as I said, like means by the protonation a protonium ion is that obtained, where this one can behave as a good living group. This part can behave as a good living group. So how can be removed as a living group? Means like this one should be means minus H2O, means HOH. Then how can we write the compound? Hmm? See, CH3, C, CH3. Otherwise, for our easy process, this compound just I'm trying to write down like this for your that easy purpose is CS3. Just I'm trying to rotate like this, beta. Okay, na? Yeah, just I rotated like this. So here, whenever this that leaving groups is that leaves, here that carbon valency is that lowered and forms carbocation. So once that carbocation is that obtained, obviously we know it favored Sn1, isn't it now? So once the carbocation is obtained, then this that X minus his attacks over here. This one can attack over here like this, like this, like this, like this. Okay. Yes. Then how can we write the final product? And attacking a what? And attacking a what? Nucleophile. Anukundam. Ante halide ion. Then the product can be written like CH3, C, CH3, CH3, and X. That means that RX, alkyl halide, is obtained. So this is the conversion of what? Alcohols. Mm, just a moment. Beta. So as I said, it is belongs to what? Is a alcohol, ROH. Okay. We converted that alcohols into, so this type of mechanism can be helped for the conversions. Okay. How to convert that alcohols to alkyl halide? So here that is belongs to what type of alcohol? Tertiary alcohols. Here halide zone halides is also use that tertiary alkyl halides. Clear beta? Chalo. Yeah, here ఏమవుతుంది బేటా ఇక్కడ. So here the once the carbocation is obtained, it follows, sorry, this color, yeah, it follows SN1. Okay. See, so here I would like to mm, means the conversion of this that alcohols through this step. ఈ step నుంచి just we can uh, move to in that another way also like that. ఇంకొక వే కూడా అది కూడా చూపిస్తాను చూడండి. So the carbocation is formed in SN1. Once again, what I am saying, the carbocation formed in SN1 is also, whenever it loses a proton, it gives first that alkenes. What I am saying? Huh? What I am saying, beta? Just a moment. Oh, sorry. Yeah, what I said in Japan, the carbocation. What is that? The carbocation hmm, form అయింది కదా ఇక్కడ బట. The carbocation formed in SN1. Okay. Also lose a proton. Also lose a proton to give alkene. ఓకే, అంటే ఒక డబ్లీ బాండెడ్ కాంపౌండ్ అనేది ఫామ్ అవుతుంది. మరి ఆల్కీన్స్ ని హౌ టు కన్వర్ట్ దిస్ దట్ ఆల్కీన్స్? ఓకే, ఎలా కన్వర్ట్ చేస్తాం ఆల్కీన్స్ ని? ఆల్కహాల్స్ లాగా. దెన్ హౌ టు కన్వర్ట్, హౌ టు కన్వర్ట్ alkenes to alkyl halide. మనకు కావాలి alkyl halide. This one, isn't it now? How to convert that alkenes to alkyl halides? Answer. ఎలా చెప్పొచ్చు బేటా? How to convert? Tell me. So whenever this that alkene compounds is reacts with the hydrogen halides. Okay. Addition with what? Addition reaction. Okay. Addition reaction with దేంతో అని చెప్పాను నేను? HX hydrogen halides. Sorry, with HX RER. With the hydrogen halides, then it gives to give ఏమిస్తుంది? Alkyl halides. This is the main important points. Okay, the carbocation is formed in that Sn1 is also whenever it loses a proton to give alkenes. ఎలా ఇస్తుందో చూపిస్తాను నేను. ఓకేనా? From the same compound. See, the same compound for your that easy understanding purpose, just I can write like this because this is the carbocation, isn't it now? And what about this one? This is that alpha carbon, this one is also alpha carbon, and this one is also alpha carbon. So total how many number of alpha hydrogens are there? Alpha hydrogens. What is the main reactivity? ఏం చేస్తుంది? the alpha hydrogens can releases the H plus ions, means that acidic nature. So total number of how many number of alpha hydrogens are there? How many number of 3 plus 3 plus 3? So 9, isn't it now? So దీన్ని నేను ఎలా రాస్తున్నాను? శివుడా, yes, like this. CH3 CH3 CH3. Here the carbocation, the same compound for your that easy purpose, just I written like this. So this is that alpha carbon now, isn't it now? And this is that alpha hydrogen. So any one of that hydrogen, alpha hydrogen, ఏమవుతుంది? can move towards here carbocation. అంటే ఇప్పుడు ఏమవుతుంది ఇక్కడ? here the double bond is obtained, isn't it na? Here the double bond is obtained and loss of this hydrogen. So this C is H plus beta. Okay, means leaving because it is that acidic hydrogen. Okay, it is the acidic hydrogen. ఏం చేస్తుంది ఇది? minus H plus. Then how can we write the same compound? CH3 C double bond comes over here. This CH3 is converted as CH2 and this is CH3. Like this, one of the alkene compound is obtained. As I said, now this one, see the carbocation formed in that Sn1, whenever it loses a proton, it gives ఏమిస్తుందని చెప్పాను నేను? alkene. So how these that alkenes are converted to alkyl halides? By addition of what? By addition of what? ఏం యాడ్ చేసినప్పుడు? by addition of HX. Yeah, H plus X minus. So whenever this that hydrogen, so X minus. So the negatively charged is mostly attacked at this, that positively charged means that ikkada carbocation దగ్గర ఇక్కడ attack అవుతుంది. Then this that H plus ion can attack over here at this carbon, means unsaturation దగ్గర ఏ కార్బన్ కి అయితే హైడ్రోజన్స్ ఎక్కువ ఉన్నాయో that positively charged, this simply we can say as that electrophile. ఏమంటాం దీన్ని? electrophile. Then what about this one? Nucleophile. Okay. Chalo, then how can we write? ఈ H ప్లస్ ఇక్కడ అటాక్ అవుతే ఏమవుతుంది, ఇది డబుల్ బాండ్ కి వస్తే సింగిల్ బాండ్, దెన్ CH2 is converted as CS3. ఓకే, CH3 C single bond CH3 CS3, and this nucleophile of that X minus is attacked over here like this. See beta, same na, same na. So this is the conversion method. Clear? How to convert that alcohols to first alkenes, otherwise that directly alkyl halide, otherwise that first alkenes, and alkenes ki ఏం చేస్తున్నాం ఇక్కడ, addition of is the addition reaction with the దేంతో అనేది addition reaction with the HX hydrogen halides. Hydrogen halide లో కూడా మళ్ళీ అది ఏది రియాక్టివ్, hydrogen halide లో కూడా which one is having that more reactive, hydrogen iodide, after that hydrogen bromide, after that hydrogen chloride. Okay, don't forget this one. That's it. Next, okay guys, so according to all these phenomena, we can get that one conclude like what is that, alcohols gives here the substitution reactions but not that elimination. Okay, alcohols gives only substitution products like this but not elimination products with the HX. Okay, very important point, please note that. What is that, alcohols gives only substitution products with the HX but not elimination products. Why? Because HX low X minus is a very weak base, we know that. It ఈ X మైనస్ ఏం చేస్తుంది, ఇది ఈ X మైనస్ ఇది X మైనస్ అంటే Cl మైనస్ కానీ Br మైనస్ ఆర్ iodide ion, so these parts. Okay, this one Cl minus Br minus or iodide minus. Okay, I minus ఇది ఏం చేస్తుంది, X minus, it is a very means X minus is a weak base. X minus is a weak base, so which it cannot abstract a proton. ఈ వీక్ బేస్ ఫామ్ కావడం వల్ల ఏం చేస్తుంది, ఇట్ కెనాట్ అబ్స్ట్రాక్ట్ అంటే తీసుకోదన్నమాట, అబ్స్ట్రాక్ట్ ప్రోటాన్. ప్రోటాన్ మీన్స్ దట్ హైడ్రోజన్ అనమాట. ప్రోటాన్ ఎక్కడి నుంచి, ఫ్రమ్ ఇదిగో మనం బీటా కార్బన్ తీసుకుంటున్నాం కదా ఇక్కడ, ఇజంట్ ఇట్ నా, ఫ్రమ్ ఎ బీటా కార్బన్, వెరీ ఇంపార్టెంట్ పాయింట్, ఫ్రమ్ ఎ బీటా కార్బన్. Clear? Okay, so based on this, that now I can give that example, then you can understand. Okay, see better. So this example I think that we are already learned. So CS3 CH2H and one reacts with that reagent like HX. So first H plus you can move to here. Okay, and the formation of that protonium ion, that remaining that X minus can attack on it, that adjacent carbon. Okay, so whenever that X minus is attacked here, it can be, sorry, whenever that protonium ion is obtained, it can make good living group, isn't it na? Can be as a good living group. Then how can we write the product? On addition of attacking of nucleophile here, this that carbo, whenever it leaves here, that carbocation is obtained, so then it follows that Sn1 follows Sn1. Then how can we write the product, CH3 CH2 and X alkyl halide is obtained. Okay, on loss of what beta, water, H2O. Okay, like this. So don't forget the statement whatever I said. What is that? The alcohols gives only the substitution reaction, but not that elimination reactions products. Why? The reason is that the X minus is that very weakly basic, so that's why it cannot get the abstracted a proton from the alpha and beta carbon. It నుంచి అది abstract చేయలేదన్నమాట. ఓకేనా? That's it. Next, okay. Now, next we can learn that Sn2 reaction. In this method only, that reaction Sn reactions of alcohols law till now just we taken that example of Sn1. Next go to that Sn2 reaction. Okay. Okay, guys. Now let us know about that Sn2 reactions for that alcohols. Like generally we know that Sn2 reactions is mainly favored by what? Hmm? Sn2 reactions is mainly favored by that primary alcohols only, and so whenever the primary alcohols means like this, okay. Like CH3 CH2 OH. This is that example about, so the OH group, that alcohol is going to be attached to those carbon, is going to be adding with that another only one carbon is known as that. So this is the good example for that primary alcohol. So whenever the primary alcohol of beta carbon, this is that alpha, this is the beta carbon. Okay. So when primary alcohols of that beta carbon is again that primary or that secondary, this is that primary, because this beta carbon is again adding with that only another one carbon. So this is the primary carbon. So secondary carbon means just decrease the one hydrogen, add one more CH3, like that, like this. CH3 CH2 CH2 OH, propyl alcohol. Understood na? Like idi alpha beta. So beta carbon is now is a secondary, because this that beta carbon is going to be connecting with that another two carbons, isn't it now? So when a primary alcohol of beta, when this is the primary alcohol, okay, when the primary alcohol of beta carbon is again the primary or secondary, gives these two examples is gives what? Sn2 mechanism or Sn2 reaction. So whenever these the substrate is going to be reacts with that HX, like HCl తీసుకున్నామే అనుకోండి, ఓకేనా? So we know that chlorine is a poor nucleophile. See that nucleophilicity అంటే దాని nucleophilic iodine కి ఎక్కువ ఉందన్నమాట మనకు తెలుసు. Whereas that chlorine Cl minus is a what? Poor nucleophile. Iodine minus is a strong nucleophile. This one is that strong nucleophile. Is a strong nucleophile. Whereas that Cl minus is a weak nucleophile. So that's why in HX law, suppose if that chlorine is taken as that reagent, if the reagent is that HCl, then the reaction would be that very slow, because it is that very poor nucleophile. So hence, we to increase that reactivity, that means that rate, we know that catalyst is used. So what is the catalyst? Means that anhydrous zinc chloride. What is that catalyst here? Anhydrous zinc chloride is that used. Okay, chalo beta. Based on this, that I would like to give that one example for this one. So see beta, so this is the primary alcohol, the example, isn't it? So primary alcohol lo intidi, this is the alpha carbon and beta carbon. So beta carbon in this again should be that primary or secondary. So here it is that primary, then it follows Sn2, isn't it? So ఇందులో ఏమవుతుంది, ఇప్పుడు HCl ని యూజ్ చేస్తాం, being as that poor nucleophile of this that Cl minus. So that's why ZnCl2 can be used as that catalyst. So ఇప్పుడు ఇది ఏమవుతుంది, catalyst oxygen దీంతో రియాక్ట్ అయిపోయి then the product is formed like this. See, we can write like this: CH3 CH2 O That hydrogen I am taking here, and ZnCl2 I am writing over here. So that's why now the here oxygen came వస్తుంది ఇప్పుడు పాజిటివ్ చార్జ్, isn't it? ఇప్పుడు క్లోరైడ్ అంటే HCl లో Cl మైనస్ ఇప్పుడు ఎక్కడ ఏ కార్బన్ కి అటాక్ అవుతుంది బేటా? టెల్ మీ. దిస్ వన్. Now this one should be attacked over on this carbon, isn't it? Na in that previous part, previous video, just check it once. Then the product can be written like this. CH3CH2. So this is now this one can behave as a good living group, isn't it? Na then how can we write directly? CH3 CH2 Cl. Okay, CH3CH2OH is converted to CH3CH2Cl. What is the byproduct? బయటికి ఏం వెళ్ళిపోతుంది బట్ ZnOH Cl. ఓకే, ఎలా ZnOH Cl2 లో Cl ఒకటి ఇలా కలిసి ఇంకొక క్లోరిన్ can behave as a nucleophile Cl2. Clear? That's it. So this is the good example for this part, the first part. Chalo, second part ఏంటి బేటా? ఇప్పుడు the alcohols is also converted into into alkyl halides by using these reagents like the PX3 low PBr3 PCl3, otherwise that SOCl2 means that thionyl chloride. What is that? Alcohols is also converted into alkyl halides by using the reagents like PBr3 PCl3 and SOCl2 thionyl chloride. So these reagents ఇది ఏం చేస్తుంది తెలుసా, which can help to form that intermediate compound like that reaction intermediate with a good living group like this. ఇది ఇప్పుడు reactive intermediate అన్నమాట. Reactive intermediate which is having a good living group, this one. Okay, next. So primary and secondary alcohols, this is the primary, and I didn't give the example for that secondary alcohol, and you know better. So when the primary and that secondary alcohols can react with that, these the PX3 like Br3 Cl3 or I3 below at the room temperature by Sn2 mechanism is reacts with the beta primary and secondary alcohols is reacts with the PX3 below at the room temperature by Sn2 mechanism. Hence అందుకే ఏమవుతుంది బేటా, అక్కడ రీఅరేంజ్మెంట్ ప్రొడక్ట్ అన్నది ఫామ్ కాదు. దేర్ ఆర్ నో రీఅరేంజ్డ్ ప్రొడక్ట్స్. ఓకే, వెరీ ఇంపార్టెంట్ పాయింట్ దిస్ వన్. క్లియర్? ఓకేనా? చలో. So here in that next we can check that mechanism for this, that Sn2 reaction beta. Okay na? Let us go for that mechanism. Yeah, see beta. So in this that Sn2 reaction mechanism, first here that alcohol is taken, then reacts with that PBr3. This one that can attack at that phosphorus, and one of that halide ion can be leaved as that living group ఒకటి బయటికి వెళ్ళిపోతుంది. సో దెన్ ఈ ప్రొడక్ట్ ని మనం జస్ట్ ఇలా రాసుకోవచ్చు. సి ఆర్ ఓ, ఈ హైడ్రోజన్ జస్ట్ ఫర్ ఎవర్ దట్ ఈజీ పర్పస్ జస్ట్ ఐ రిటర్న్, అండ్ దట్ PBr2 కెన్ అటాక్ ఓవర్ హియర్ ఆన్ లాస్ ఆఫ్ దట్ Br minus. సో దిస్ Br minus హియర్, this Br minus can act as a nucleophile and displaces. ఈ న్యూక్లియోఫైల్ ఇది ఏం చేస్తుంది, దేన్ని డిస్ప్లే చేస్తుంది బేటా? ఈ OHPBr2 ఉంది కదా, దిస్ వన్ ని ఇంకో దీన్ని డిస్ప్లే చేస్తుంది, అంటే తీసేస్తుంది యాజ్ ఎ గుడ్ లివింగ్ గ్రూప్. మరి అటాకింగ్ గ్రూప్ ఏదవుతుంది ఇప్పుడు? ఇది దిస్ వన్ Br మైనస్. ఓకే, అటాకింగ్ గ్రూప్ అవుతుంది as a nucleophile, isn't it na? Followed by that Sn2. So RBr అనేది ఫామ్ అవుతుంది ఇట్లా. Okay, like this, that alkyl bromide, alkyl halide is that obtained and remaining that byproduct, but there is no rearranged product. Okay నా, గుర్తు పెట్టేసుకుంటది. ఓకే, మనం ఇంత ముందు చెప్పుకున్నాం. ఓకే, చలో బేటా. సో Next, few more important points. See, better here I would like to say that the two important of PX3 and SOCL2. Okay. So what is the main importance of PX3? So PX3 and SOCL2 can be used as what? Reagents, isn't it? Na? We know that. These are the reagents. So that PX3 is a reagent when it reacts with the tertiary alcohols. Okay. When it reacts with what? Tertiary alcohols. Then it gives Sn1. Okay. Generally we know that lower the Sn1 అంటే చిన్న నెంబర్ పెద్ద దాంతో రియాక్టివిటీ ఉంటుంది అలా గుర్తుపెట్టేసుకుందాం. మరి SOCl2 ఏంటి బేట? SOCl2 when it reacts with దేంతో బేట? ప్రైమరీ అండ్ సెకండరీ ఆల్కహాల్స్ తో రియాక్ట్ చేసినప్పుడు ఏంటది? whenever the thionyl chloride gives Sn2 దేంతో? ప్రైమరీ అండ్ సెకండరీ ఆల్కహాల్స్. అదే ఇప్పుడు టెర్షరీ ఆల్కహాల్ తో అయితే obviously Sn1. This is the very general thing. Okay. Okay. Okay, guys. So this is the end part of this uh, Sn reactions of that alcohols. Okay. So in the next part of that video, just we are going to learn that Sn reactions by that ethers beta. Okay now. So just till then, bye bye. See you. Have a good day. Take care and prepare well, practice well, do hard work. Okay. The main thing that what I given in that statements like always like that revise daily 1 hour. The organic chemistry ki daily 1 hour minimum we have to spend the time with that organic chemistry. Then that organic chemistry can love us. Okay na? So when it let love us, then we will be that very happier and that we can practice more and that more number of that questions we can practice in the DPP levels. Okay na? Chalo beta, bye bye. See you in the next part of the video of what Sn reactions by ethers.